Good morning. My name is Rahul Gupta, and it is my pleasure to present to you today Sunco Tracking. Sunco produces passive solar trackers for commercial and residential purposes. Humans have relied on fossil fuels for far too long, and what we're starting to see is that the impact extends beyond economic harms and moves to affect the human condition itself. We use China as a case study, where each year 1.1 million people die prematurely because of pollution-related causes. When you aggregate the total externalities and the medical costs, you approach approximately 1.34% of real GDP loss associated with pollution in China. You only have to look outside your window in Beijing to see the tangible impacts of pollution that it has on everyday life. But we don't have to go overseas in order to see the effect of fossil fuels. Take Texas, where 100% of coal plants contaminate the groundwater in our state. This is the water we drink, the one we bathe in. This is what our children drink and bathe in. And what we're looking at is generations upon generations of disease and disability caused by the chemicals and carcinogens we're putting in our water today. That's our fault. And at Sunco, we find this unacceptable. More and more, the data shows that Americans find this unacceptable. And we're seeing changes. Last year, 30% of the new energy capacity in the United States was in the form of solar. 1.8 million homes now have solar panels on their roofs. And 90% of new solar installs have active trackers or passive trackers on them. What is a solar tracker? Basically, a conventional solar panel is fixed on a roof like this. But the sun's always moving across the sky. So what a tracker does is it allows the panel to move throughout the day in order to maximize the amount of sunlight that's hitting it during any point in the day. And by doing this, you optimize the amount of energy output that you're getting from that solar panel. We have estimated a $7 billion market cap for us, as well as a $36 billion total addressable market space. There's opportunity for us to enter, and we are doing so now. So what's available on the market right now? Well, we've outlined what is typically known as an active system. Now, an active system involves some sort of technological component to it, and that component may have a microcontroller, it has a motor, it has a battery, and these components are very expensive and very difficult to maintain. You have to have someone come out and recalibrate them at every 3 to 6 months, and because of that, you need a very high-paid and high-cost individual doing that. That raises the amount of money that you're going to be spending on the maintenance of your costs and the installation, so the entire life of your system. What Sunco does is we create a passive tracker. And a passive tracker is able to eliminate some of these more expensive components to reduce the initial cost as well as the maintenance cost throughout the duration and life cycle of your solar system. We believe by doing this, we make it more accessible for residential owners as well as small business owners to implement solar in their system themselves. So what's unique about our passive tracker? We use something called a shape memory alloy. Now, shape memory alloy is a type of metal that's composed of both titanium and nickel. And it has a unique characteristic in that at certain temperatures, it starts to expand and contract. Now, this is pretty cool because what we can do is we can change the composition of titanium and nickel to have it expand and contract at different temperatures. And now, if we think about the sun as it goes up and down through the sky, the temperature changes during the day. So if we put a number of these springs in a series, we can have the expansions and contractions happening at different times. And by doing that, we create continuous movement throughout the day in order to optimize the amount of sunlight hitting the panel. Through this, we're able to achieve an 18% increase in output from these solar panels in lab testing. We believe we're going to be able to hit 25% by the end of the year. We're able to do this at 10% of the cost of traditional active trackers. And that's huge because that allows us to gain access to the residential and small business market. Another unique key characteristic is that we are retrofit capable. If you already have solar panels on your roof, you can add our system on top of it in order to make sure that you're maximizing the amount of sustainability you achieve through your panels themselves. At Sunco, we believe that people who've already invested in sustainable energy should have the opportunity to maximize on the latest innovations themselves instead of having to wait 20 years to install a new system. And finally, I want to emphasize cost again because our system only costs $500 compared to the $5,000 of an active tracker. Now, the $500 cost comes about because we've been prototyping based on off-the-shelf material we buy from Home Depot. Once we start manufacturing at a much larger scale, we're going to be able to reduce these costs substantially, and we're expecting to achieve about a 95% cost reduction in comparison to the active trackers themselves. Now, as soon as you think about putting metal outside, you've got all sorts of concerns, especially on like a day like today. Is it going to rust? How long is it going to last? Well, shape memory alloys are actually used in some of the most toxic conditions and environments on Earth. As an example, take the mouth of an everyday teenager. Braces use shape memory alloys in order to reshape the teeth. And if you think about all the candy, soda, and coffee that your average teenager is eating, yeah, those shape memory alloys are pretty durable. But in a more industrial setting, you have shape memory alloys used at nuclear reactors. Basically, if all other systems fail during a nuclear meltdown, scientists rely on these shape memory alloys to actuate at a very high temperature in order to kill all the systems. This level of reliability is essential to our design. The next concern that we often get asked is, what about the accuracy? Well, what we're doing is we're changing the composition of the alloys themselves in order to make sure that they actuate at the exact temperature that we want them. And by stringing together multiple numbers of these shape memory alloys, we're able to actuate at different time periods in order to get the full range of temperature that we hope to achieve at a certain geographic location. And that's huge for ensuring that we're getting that 18% output in all locations. Next is manufacturing. Shape memory alloys sounds super technical. How are we going to get that done at a cheap fashion? But we've identified 2 manufacturers in the United States, one in Indiana and one in California, that are actually working with us to develop the shape memory alloys for the prototypes themselves, have expressed willingness to engage in mass production of these shape memory alloys. I'll talk a little bit more about that partnership in just a little bit. And finally, competition. We think this is such an important feature that we decided to dedicate a slide to it. So our competition is really divided into a couple different sections. 2 big ones is passive and active tracking. We are passive, the other competitors are mostly active tracking. Now, within all of the solar panel usage, there's a number of subsections that we want to consider. And as you can see, most of the active trackers are used at the utility scale. What this means is you have giant solar farms that are using solar energy to supply the power grid. Now, these active trackers can be massive, and they're put on the ground and used to move multiple panels at one time. And so these utility companies are able to utilize active trackers because of economies of scale. They're able to spread out the cost through multiple systems, and by doing that, they're able to make it cost effective. But your neighborhood Target or Walmart can't put a bunch of solar panels on the ground. And they surely can't put an active tracker on the roof or it will cause it to cave in. So we target that market, where individuals who can't put more than 45 pounds of weight on their roof, which is the regulations for most households, can utilize our system instead in order to mount the solar panels in a cost-effective way on the roof. Now, we do have one competitor in the passive tracker market, and that's Zomworks. But Zomworks has a few key features of their designs that aren't going to have them be successful in the specific area we're targeting. Specifically, their design uses pistons which contain gas and liquids within them in order to actuate at certain temperatures. But in order to make sure it actuates at the right temperature, they have to do a lot of geographically centric testing and implementation at the site. This can require months on end of testing on the rooftop of whatever location or on the ground if the roof can't support that weight. Because of that, it's inaccessible to residential and small business owners. Because of that, we are the only company that's seeking to enter this space, which makes us unique and offers us an exciting market to enter. At Sunco, our value and sustainability extends beyond just ensuring it to Americans. We believe that anyone around the world who has an interest in sustainability should be able to access it. We've partnered with the hospital in Pakistan in order to see if we can increase their energy output using solar. This hospital does all sorts of medical procedures, but they face a unique challenge in that they have 8 to 14 hours of power outages each day. In order to fix that problem, they have 2 large generators that produce the energy during that time period. But these generators produce a ridiculous amount of greenhouse gases. And that air is right next to the hospital, and it cannot be good for the patients who are staying inside. Recently, the hospital installed solar panels. But the problem is they aren't able to get enough energy output from these solar panels themselves in order to completely replace those generators. We hope that by implementing our system with Sawira, we're going to be able to reduce their need on the generators themselves so that they can improve the quality of care their patients receive. We value sustainability more than anything else, and we believe it should be accessible to all of these locations and all of these hospitals around the world. Our timeline for implementation is very intense, and we're looking at a 1-year time frame that we really want to get things rolling. Fundraising is going on as I speak, and we have a lofty goal of $700,000. However, we recently applied to a $250,000 grant from the Department of Energy for small businesses, and we're hopeful that by earning that grant, we're going to be able to meet a large portion of that goal. We're also seeking the partnerships with the manufacturing plants that I talked about earlier to be able to mass produce these shape memory alloys and have a constant supply for implementation. And finally, improving the system itself, we believe we're going to be able to achieve a 30% accuracy rate in the long run, and we're going to be working towards that through continued prototyping and improvements on our design. Finally, implementation. We're currently working to have a new test bank set up in California. We have an existing one in Houston, and we're currently talking to Shell as well to see if we can implement our design at their microgrid in Houston. Our team is composed of 4 past and present UT engineers. Taylor Zhao is our power systems guru. He loves solar panels, and he's been kind of taking the lead on the mathematics behind that one. He was in California yesterday pitching to Shell to talk about the microgrid a little bit more. Mandeep was at MIT yesterday talking at their clean energy pitch, where he was seeking funding for our design as well. He's a mechanical engineer, and he works mostly on the back-end design to make sure we can implement accordingly. Katie is a BME. She works with shape memory alloys, and she's helping us implement those with our designer themselves. I'm focused mostly on the economic policy of it and seeing how we can use the Bertrand pricing model in order to make sure that we maximize our profits. We have a number of advisors that have been crucial through our process. Cynthia and Kristen have given us a lot of technical and business advice, but I want to give a special shout out to Dr. Connolly, who's our advisor at UT, who's been able to help us get a lot of resources on campus to make our project successful. With that, I'd like to conclude my presentation and open the floor for any questions. Thank you.
Thank you very much for the presentation.
Thank you.
Question, so you have the product currently in test mode today?
In test mode in Houston, yes,
in
sir.
Houston?
Yes, sir.
And what kind of results if you've
Sure.
gotten from that?
So there's 2 parts of testing that we've had. We've done the laboratory testing at a significant scale, and through that we've achieved the 18% output generation. In the field itself, we don't have enough funding in order to implement it on a wide scale, so our results that we're getting right now aren't substantial enough for us to provide the statistical significance we want to provide at this time to guarantee. Okay. Now, because of that, we're geographically confined to Houston, and we spent the majority of the funding we had on getting our patent approved. Okay. So with that, we're seeking more funding so we can expand to California and the Shell microgrid in order to implement at that scale and provide more valid results on the field testing side.
Good, thank you.
Your presentation also had something about Pakistan, though.
Yes.
I think that risks you guys looking unfocused, because you said you're having a tough time capturing Houston or Austin, never mind Pakistan, and that would introduce all kinds of international risks that are not specific to the business. So I would encourage you to hone in and focus. What are the unit economics? I might have missed it, but
I'm glad you asked.
Yeah, explain the business a little bit for me.
Let me get to this slide here. So these are our costs for production of the systems themselves. On the, I want to make sure I get the orientation right. On the left, I believe you have the cost for a brand new system itself. So if you don't have solar panels and you're planning on installing solar panels, you can use this list of materials in order to produce your system and make it compatible with our passive tracker. That's, I believe, approximately $300. If you already have a system in place, there's certain pieces that don't need to be implemented themselves. We're looking at a cost of only $200 for the system.
Cool, yeah.
For the payback period, it is 2 years for the system as a whole.
Okay.
Enjoyed your presentation. Thank you
you
so much. Just curious, since homes are a great opportunity and you're doing the testing, when are you going to actually do more in the residential area, since that seems to be one of the biggest opportunities?
Definitely. So we are actually in conversations with multiple installation companies in 2 geographic locations, California and Texas, to see if we can get a test site in place in order for us to really test it on a wide scale. Right now, we're testing a 6 kilowatt system. We really want to be achieving a 30 kilowatt system if we have substantial funding by the end of the year, and that would be on a residential setting.
And with the growth of homes here in Texas specifically, and especially down where you guys are, Have you looked into maybe partnering with a home builder to kind of really prove this out?
Definitely. So that is a great opportunity for us to really enter in. We want to make sure that we're partnering with the solar installers themselves first, and we would like to see a solar installer that's partnered with a home builder in order to achieve that partnership. With our system itself, with any solar system, there are inspections that need to be done on a 6-month basis or a 3-month basis, depending on your system. And because of that, that will be done by the installer themselves, as will the maintenance on our system if any is needed. And through that, we want to make sure we're in partnership with them.
And then I would encourage you, assuming everything goes well, to think about incentives because, I think that the residential market is a huge, huge opportunity for you.
Definitely. And kind of on that note itself, I just passed it. So we are expecting to see an increase in the amount of capacity of United States itself in solar market. And in 2020, we're seeing a lot of the solar benefits actually go away because of different cuts that have been made during the Trump administration. However, we do believe that this will change in the future. And as people see the viability of solar more and more, they're going to be transitioning to that. So the benefits themselves are already in place within our system. We actually are able to achieve approximately the equivalent return of a 20-year or 30-year investment in an S&P 500 share through the implementation of our system. So we believe that we're making it viable in and of itself, and the benefits from the federal government are just cherry on top.
Ariel, very good job.
Thank you.
A couple questions for you. When you use the word system, that means one system per panel, is that correct? So on a residential install where you've got 40 panels, you're talking about 40 of your...
So the total cost for the entirety of the system would be $500. Yes.
$500 for 40 of your...
Yes, that is correct.
Okay. So that I don't understand, economics either. Because residentials have different size systems.
Yeah. So on that note, we are assuming a 10 kilowatt system itself.
Okay.
As you scale, it's going to affect the house, of course, and based on that, you'll have different returns to scale. Our
Second
baseline assumption is 10 kilowatts.
Part of the question is operational, because this becomes truck rolls and actual construction.
Yes.
Are you guys targeting greenfield or retros at first, or both?
We will be able to target both, and it will be done with the installers in collaboration with the installer. It really depends if they're more comfortable with doing the retrofit or the green, depending on who that first installer is. That might be our focus. But again, we really need to be looking more to getting that first contract first and talking to them to see what their intentions and willingness are.
Okay. And so the other thing, it leads to the question on the financials. Most of us up here are looking at startups, and looking at your financials 5 years out, you look at maybe $5 million in revenue. For us at the table here, that seems awful small for a market that is as big as it is. What's the inhibitor to growth, and what's holding you back from getting to $30 million in 5 years?
Yeah, so the big thing right now is scale. So we really need to be in works with some sort of contractor in order to determine how we can, manufacture these at a large scale. We can't do it ourselves in our garage with Home Depot supplies. So over the next 12 to 18 months, that's going to be our main focus. How can we scale this in order to achieve a larger market space and be able to capitalize on the growth that's occurring right now?
Great, thank you.
Thank you.
Yeah, my question is around product supply. What are you relying upon as far as product to create this device to do this type of transformation that you're talking about? Are we talking about having to source product from offshore, or are they all made here in the United States?
Definitely. So the shape memory alloys are produced in the United States themselves. So those two can come from the United States. The rest of the parts that create the framework for the actual solar panel itself can be produced overseas or in the United States. We would prefer United States, but again, if it's cheaper overseas, as a small startup, we're going to have to consider doing that as well. Those will come from traditional solar panel manufacturers with modifications to fit our design as needed, and we're confident that we'd be able to achieve that within the next 12 to 18 months.
Good, thank you.
Where are the raw materials sourced? Titanium and nickel.
We're not aware of that. At least I'm not. I guess it's only 25% of the total intelligence of our team here. So the shape memory alloys, we're just relying on the manufacturers themselves to provide that, and they've expressed the willingness and ability to scale as we need.
And then who actually owns the patent, and when will you secure, what's the date that you anticipate you'll secure the patent?
Sure. So we own the patent.
And, yeah, who's we, the company or
The company
an
is
individual?
Sunco.
Yeah.
Sunco as a whole owns the patent, specifically Mandeep and Taylor, our co-founders. I'm not sure what the date is for the approval of the patent.
Hey, you did a great job, man. And
Thank
I
you.
really liked how you guys are focusing on the residential sector. Your competitive slide was really helpful for me in understanding just kind of your go-to-market approach. And I think your contingency to success is really going to be learning how to resonate in that residential sector. You're off to a great start with a great name like Sunco. And then it's just going to be about making the unit economics make sense.
Definitely. Appreciate it.
Great job.
I would echo that. I agree. I think it's a huge, huge market. I'd say go for it, but be really focused.
Yeah, we'll do. Thank you.
Please join me in thanking Raul and the organization.
Thank you.